Hi everyone, we're going to have a little bit of a quick lesson on graphing straight lines. Okay, the big thing to remember when we're graphing straight lines is we have our two axes, our x and y axis. If a line is going in an upwards direction from left to right, we say that is a positive gradient. And if a line is coming in the opposite direction, so downwards in a left to right direction, we call that a negative gradient. If a line is going straight across from left to right, so it's horizontal, we call that a zero gradient. A gradient, having a constant gradient, is what defines a straight line. So we can have other lines, curves, we can have periodic functions that look like waves, but all of these other graphs have varying gradients. So straight lines have constant gradients. They're the only type of lines with constant gradients. So that's what defines them. We learned in Year 9 that a gradient describes the slope of a line. Okay, so the steeper the line, the bigger the gradient, and the shallower the line, the smaller the gradient. Remember that we can find the gradient by thinking in a couple of different ways. Gradient can be found by going rise over the run. So that's how much we go upwards or downwards as we go across. So if we have a look on a bigger graph, this is a line that has a positive gradient. If we look at how much it goes across, which is the run, and then how much it goes up, that's the rise, that gives us a definition of how steep that line is. So the gradient is a ratio between the run and the rise. If we have a negative gradient, like this line here, we still go across from left to right, but instead of going up, we go down for the rise. So the rise is going to be negative. We still go from left to right for the run. So we still got a triangle, but it's just going the other way. Another way to think about the gradient, which we've had a look at before, if you have 2 points on your line, and we look at the rise and the run, if the first point here is x1, y1, and the second point is x2, y2, the run is the difference between those two x values. So the run is the difference between those two x values. And that means the rise is the difference between the two y values. So that's how we get the other formula for the gradient, which is y2 minus y1 over x2 minus x1. So we have seen that one before as well, and that one's very important. Now, in order to sketch a line, we need two things. We need 2 points, and we can get those 2 points in a number of different ways. Firstly, if we have an equation for a linear line, where we can see the gradient and the y-intercept. Firstly, if I write down the gradient is +2 and the y-intercept is 5, all I have to do is on my sketch, first of all, I mark on the y-intercept, so 1, 2, 3, 4, 5. Mark that on, that's our first point, so that gives us point number 1, and then we use our gradient to find another point. So when it's a gradient of 2, what that actually means is it's 2 over 1. So we go up 2 for the rise and across 1 for the run. So we go across 1 and then up 2. And that gives us our second point here at the point 1, 7. Now, in order to draw the equation, that line for that equation, all we have to do is join those two dots together. And that's how we would join that. Occasionally, we might get given a graph where you can't see the gradient or the y-intercept. So we might get given a graph like this, an equation like this. Okay, so when the linear line is in this form, you can't see the gradient, I can't see the y-intercept. So what I would do is I use the intercept method instead. I find the two intercepts. So the x-intercept occurs when y equals 0, and the y-intercept occurs when x equals 0. So to find the x-intercept, we just substitute in y equals 0 into the equation. So we cross the x-axis at x equals 3. And we cross the y-axis at y equals 2. So to sketch this equation, we just mark those points on the graph. So y equals 2, that's my first point there. And my second point is going to be x equals 3. And we just join those 2 points up. Sometimes we might get asked to describe or to match up the gradients with the equation. So if we have 3 lines here, I can look at line number 1, this A line, A curve, and I can say that's a positive gradient. I can say it's shallow. And if it's shallow, it means that the gradient is between 0 and 1, so it's less than 1. If I have a look at this line here, if at the B line, it's going straight across, so it's horizontal, that means the gradient equals 0. So I can see a lot just from looking at the sketch of a line. Now if we look at the line C, first of all I can see it's negative because it's going downwards. It's relatively steep, which means the gradient is greater than 1. So we can see a lot just from looking at the equation, the sketches of the line in terms of matching them up with the equations. So I hope this helps. There are some questions in the book. Okay, guys.